Hello, everybody. Okay, so let's take a look. After quadratics, I think we'll find that this is a much needed break. So we are moving on to data. And what we're going to do with data is we're going to interpret graphs, draw graphs. We're going to find measures of central tendency. We're going to do statistics and probability and that sort of thing. But today we are just reading and interpreting graphs. You will find this, I promise, to be so easy you won't even know what to do with yourself. So if you take a look at this graph right here that I'm labeling A, it is percent humidity. And if you go on the x-axis, we of course are looking at time. If we go to the y-axis, we're looking at percent. Now, what I want to point out is this little thing right here. Whenever you see a break like that on a graph, that means that it recognizes that it's like there's some space between data points. This jumps from 0 to 40 and then 40 to 50, but like the space between 40 and 50 is about the same as 0 to 40. And so this is just the graph's way of recognizing that, like, they know that's not correct, but they didn't have any data sets or data points really much below 40%, so they didn't want to waste the vertical space on the graph. All right, so the first question, when was the humidity the lowest? Super duper easy. Honestly, you look for the point that is the lowest Y value on the graph, which would be that one. And that occurred at 4 a.m. When was it the highest? You look for the highest point on the graph, which is right here, which occurred at 4 p.m. And then between what hours did it increase the most? Now you're looking for the largest slope. And it might be a little bit difficult to tell on this graph. It's probably either between these 2 points, so 8 a.m. and 12 p.m., or 12 p.m. and 4 p.m. And there's such a slight difference between the two that you could actually write either. If there is a little bit more distinction between them, you know, if one of them went up like this and then the other one went like that, then I think it's a lot easier to tell, right? So you can put either 8 a.m. to 12 p.m. or 12 p.m. to 4 p.m. If you want to be fancy, you can also say between 8 a.m. and 4 p.m. So you can take that whole thing. All right, so far so good, yeah? All right, excuse me, looking at graph B. We have ingredients on the y-axis, so bread, ham, turkey, cheese, and mayonnaise, and grams of fat on the x-axis. If I said x-axis on this one, I apologize, I meant y. So it goes 0, 2, 4, 6, 8, 10. This is a bar graph. This A was a line graph because there's lines between them. This is a bar graph because there are little bars of space here. And so in order to read this, like let's say ham, you go out to the end of it and you go down and you say that's 6. Okay. So which ingredient has the least amount of fat? So which bar is the smallest here? That of course would be bread. Which ingredient or ingredients have at least 8 grams of fat? So, well, I look at where 8 is, and that's going to be my cutoff point. So I need ones that are more than that. Well, this blue one, which is cheese, and the purple, which is mayonnaise. I don't know how many of you like mayonnaise. I personally, like, if you wanted to torture me, you would make me eat mayonnaise for the rest of my life because gross. But anyway, I know a lot of people like it. I don't know why I hate it so much. I just do. All right, graph C. During which months did station A charge more than station B? Well, you have to look at the key here. Station A is red. Station B is blue. So we're looking, station A charged more than station B. So where is red higher than blue is what we're looking for. So red is the same as blue here. It is higher than blue, really only at this point right here. And this is months at the bottom. So January, February, March, April, May, June, July, August, September, October, November, December. How many of you knew that you could spell Jason in there until you saw this graph? Who knew? All right, so the only point where it is higher is right here, which is the month of May. And it says months, but not really. I mean, I guess you could go from April to May and like into a little bit of June if you wanted to, kind of read the lines rather than just the data points here. So if you want to say April to like mid-May, that's fine too. Or if you just said May, that's okay. During which months are they the same? Well, April is the same and July is the same. Oops. April and July. Which station is the lowest average price during the year? And you don't really have to look and see, you don't have to get data points and average this out. You can just look at the graph and say, well, clearly for the most of the year, red is below blue. So that would be then station A had the lowest average price. All right, looking at a punch recipe. So we have ginger ale at 50%, we have orange juice at 25%, we have pineapple juice at 12.5%, and lemon sherbet at 12.5%. Which two ingredients are used equally? Well, we have two at 12.5%. That would be lemon sherbet. I always thought it was spelled sherbet. Shows how much I know. And pineapple juice. And if you guys are thinking, oh my gosh, this is like ridiculously easy, does it get a lot harder? Honestly, not really. I mean, graph interpretation is something you guys have been doing forever and ever and ever. So, which ingredient is used most? Well, 50%. That would be ginger ale. Okay, that's first page done. Let us move on. So sometimes we'll have to actually make our own graphs. And again, if you'll notice over here, we have bar graphs, line graphs, and circle graphs. And you can kind of choose which one you want to make in some of these. So we have flowers in an arrangement. We have 4 different flowers, 4 different numbers of roses, lilies, agapanthus, I think, I don't know, and peonies. So would you make a line graph, a bar graph, or a circle graph? I guess personally with this data set, I would make a bar graph. Circle graphs are cool, but 2 problems. Number 1, it's hard to draw a circle. That's a true fact. I can do it really super well on the board when I have like, the entire board to, have my arc, but a small circle is very difficult to draw. Also, you have to have an issue with central angles in a circle. Like if you want it to be accurate, you actually have to measure out the angles from the center, the angles being like back here, like this is 50%. So obviously there'd be a 180-degree angle, right? But then you have to figure out, okay, well, 25%, so that would be 90, and then 12.5, so this would be 45 and 45. So you have to split up the circle correctly in order to get 360 degrees in the middle. And we just really don't want to do that. You have to do that in geometry, so we'll wait for that. All right. So I'm going to draw my x-axis and my y-axis. And you can do a bar graph, either a horizontal bar graph that looks like this, like that. I mean, obviously those would be bars, not lines. Or you can do a vertical bar graph that looks like that. So it's up to you, whatever you choose. So my highest value here is 6, and I have a little bit wider range on my x. So I might go 1, 2, 3, 4, 5, 6. And then I'll put my flowers on the side. So this is my number of flowers and my brand of flowers, so to speak, up here. So we will go with roses, lilies, agapanthus, and peonies. And if any of you are like horticulture experts and I am pronouncing that wrong, please email me and let me know. All right, so I have 6 roses. I'm going to draw a line out here. And that should actually stop at 6, not a little beyond 6. Sorry about that. I have 4 lilies. So I'm going to draw a bar out to here for lilies. I know those of you who are like a little bit I don't want to say OCD because that's like a real thing, but you know, a little bit weird about that. I'm sorry, I'm not like filling it all in. That must be driving you crazy. Agapanthus, I also have 6. So I'm going to draw out a bar to 6. And then I have 3 peonies. So I'm going to put my end here at 3 and draw my bar graph. So there you go. There's a bar graph. Super duper easy. Okay. Now you guys are going to create a graph here. So I'm going to start this and then you are free to finish it at your leisure. So 5 things you do in a typical 24-hour period during this school year. So the funny thing is like usually when I do this, it's, you know, go to school and do my sporting events and do my homework and, you know, go to band sectionals or, you know, whatever the case may be, go babysit. And during quarantine time that your schedule probably looks a little bit different. So I'm going to do this on my schedule. I want you to fill this out, you know, as it suits you. So now, of course, my activities are online teaching, right? And that is doing stuff like this, so creating videos or having Zoom calls or grading or that kind of thing. Okay, so that's going to be one of the things I do. Probably another thing is exercise. So I do that every day. I run a lot or I bike. My dog is getting tired because we go on a lot of walks. Let's see. What else do I do? I watch a lot of Netflix. I'm not even going to tell you that I'm lying on it. Like I watch a ton of Netflix. Gotten to know a lot of shows, which has been fun. I also read and I try in a lot of different ways to communicate with my friends and family. And whether it's like on the phone or we do Zoom calls too. So that kind of thing. Okay. So then you're going to go. So as soon as you get 5, and certainly again, don't do these 5 unless this is exactly what you do, and then you can. So your time spent. So my online teaching, I probably spend about 8 hours a day. Oh, you know what else I can put on here? How about I'm going to put reading with Netflix and I'm going to put sleeping because that obviously takes up a lot of your day or night because I asked you a 24-hour period, right? So we have to sleep in there somewhere. I definitely sleep about 8 to 9 hours. So let's go with that. So 8 plus 9, I have 17. So I have, let's see, 7 hours left. I exercise. Let's see, the dog and I walk about an hour. I run for about an hour. So let's go with 2 hours. I exercise. So I have 10, 19. I have 5 more hours. I would say I communicate with friends about 1 to 2 hours a day on average. Let's go with 1. So I have 10 here and 10 here. And I definitely watch about 4 hours of Netflix or read for 4 hours. So there you go. So you'd make a graph with those. And again, it's up to you. I would do a bar graph here. You could do a circle graph. That would be a little bit, again, difficult to get your central angles in. So the largest one I have is 9. I think I'm probably going to do, you know what, I'll do a vertical bar graph for this one. So this is my activity is down on the x-axis. This is my time in hours on the y. So my highest I have is 9. 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, I guess I could have gone up further than that, but that's all right. So we'll go with teaching, exercise, Netflix, Netflix / reading, sleeping, and communicating with friends. So teaching, I do 8 hours. Exercise, 2. Netflix or reading, 4. Sleeping, that's my biggest activity. We do 9. And then communicating or chatting with friends is 1. So there you go. That's how you would set up your day. And again, like I said, that looked pretty different before. So, okay. Last page of notes we have for this lesson is what's wrong with this picture. Okay. So these are what are called misleading graphs. And there's a bunch of different reasons that a graph could be misleading. But you're like, why would anybody do a misleading graph? A lot of times you do a misleading graph to make yourself look better, right? So if you're a brand and you're trying to advertise, or you're trying to put out like a poll results from an election poll or political poll or something like that, you might try to do what's called skewing your data so that you can make it look like you have the result that you wanted. So with this one, this customer satisfaction. So the satisfaction percentage is on the y-axis, the brand is on the x-axis. And it says, which brand looks like it has the best customer satisfaction rating? Well, the highest percentage here, so this would be at 86, if you didn't label the top, would be B. And it looks like B blew these others out of the water, right? Like, oh my gosh, like B is so much better than A and C and D. But when you take a look at what's really the difference between each company's rating, well, look at the numbers here. So this A would be at 79. B is at 86. C is at 81. And D is at 83. So where it looks like B is so much higher than everything else, from the highest to the lowest, there's only a difference of 7, right? So low to high is 7%. And this graph is super misleading. And you're like, well, why? Well, remember what I said that little break means is that we skipped some data points or some numbers. Well, in this instance, we skipped 76. That's a lot to skip. And you would do that because then, like if you were to actually graph this, like 10, 20, 30, 40, 50, 60, 70, 80, 90, okay? Then you have A, B, C, D. Then you would have A at almost 80, and B at almost 90, and C at a little over 80, and D at a little over 80. And so now they look essentially the same. So like taking away 75 or 76 data points here makes it look like there's a huge difference between these, but there's really not. So like, well, who would put out, this type of graph? Who would benefit from this? For sure, brand B would, right? They don't benefit from putting something like that out because it doesn't look like there's any real measurable difference between any of these. So brand B would want to make it look like they're so much better. So this is why you have to be really super careful when you're reading things so that you're reading the actual numbers on the side and looking for this breaking point. All right, let's see. What's wrong with this circle graph? So we have, this is B, county budget from 2005. It's a long time ago. So what does it look like we spend like a ton of our money on? Road maintenance, right? Fix the roads. So, and I'm not going to finish the rest of that, but it was our governor's rallying cry for her campaign last year. Fix the blank roads. So it looks like we spend over half of the budget on road maintenance, right? But really, what do we spend that on? That's only 25%. So let's take a look at the rest of this. So I have 25%. Social services is 20%. Parks and rec is 10%. Garbage collection is 5%. So if I add all these up, what do I get? I only have 60%. So my question is, what's the other 40% of this budget being spent on, right? So that's why this graph would be misleading, because there's a whole 40% somewhere that's not even put into this graph in the first place. So that's my first problem. So problem 1 it's missing 40%. Problem 2 is that it makes it look like you're spending a ton on road maintenance, a ton of money on roads, when really, like, it looks like over half of your budget is in that, but really it's a quarter of it. So that's misleading in 2 different ways. All right. Last one on here. Who won the student council election? Well, Smith got 20%, Napier got 5%, Atkins got 10%. If you just look at this graph and you don't look at the numbers, you're like, Smith, right? Because clearly, again, wow, look at that. Smith has over 50% of this graph. Well, the problem is the same as the other. 20% plus 10% plus 5% is 35%. So that's not even like, certainly like 20% of 35% is a majority, but 20% of 100% certainly is not. So there's 65% of the vote out here that's missing still. Now, did that go to one candidate? Well, then that candidate won. Did it go to like a whole bunch of other candidates? Okay, that's fine then. But let's take a look at this. What this should look like. So there's Smith. There's Napier. There's Atkins. And there's like the rest of it, right? So this entire piece right here of the graph, which is a huge piece of that pie chart, is simply missing. So when you take it and look at it that way, and you're asked who won the election, it's whoever has this like plaid area of the vote that clearly won it. Now, again, if this is other candidates, then Smith did win. As long as you're looking at what if you take AP government, which you haven't, it's called a plurality, not a majority, meaning that, no one candidate got a majority, but Smith got the most votes of anybody who did. Okay, so those are your notes for today. And your optional assignment is this 10-1 practice C. And all you're doing, again, is just graph interpretation. And then this last one, number 7, you have to create a graph and, sorry, you couldn't see that. Create a graph and choose which type of graph, and the type meaning like a bar graph, line graph, or a circle graph. And if you're doing a circle graph, I suppose you have to be like super, super, super crazy accurate with it, but try to be as accurate as you can. All right. If you have any questions, let me know. Okie dokie, guys. That is it for today. There.